To end this section, we're going to talk about the important idea of being careful with our limits of integration. And this is going to hold true whether we're dealing with areas or arc lengths or really anything with polar coordinates. The idea here is that certain polar curves, specifically for us the polar curves that are called roses that have this flower-like shape, can oftentimes be graphed on different intervals of theta. So to see what I mean, take a look here at example number 5. I want to know how long it takes to graph out these two different curves. That is, what's the range of theta values necessary to get the full picture? Well, if I was to go ahead and actually just plug these into my calculator and try to graph them, I'll be able to see that this cosine of 2 theta ends up looking something kind of like this. I'm going to do a really bad job of sketching this out, but it's an approximation. So I get some picture that looks like this. Whereas if I was to graph out the cosine of 3 theta, I end up with something, that looks a little bit more like the following. That was one too far. I'm going to get something that looks a little bit more like this. So I kind of have something that goes back, origin, loops around like this, comes up in here, and loops back like that. So hopefully you had some pictures that are kind of similar to this. And so again, this down here is my cosine of 3 theta, and this up here is my cosine of 2 theta. And if I was to go ahead and actually see on the calculator, you can play around with your window to see that for the first picture, we need to have theta actually range from 0 to 2 pi to get the full picture. We need that to be the case. However, on the second picture down here, we need something very different. If you graph this one from 0 to 2 pi, you don't actually need all of that range of angle to get the picture. You actually only need to go from 0 up to pi to sketch this. And so this creates some potential complications when it comes to setting up bounds on integrals. Take a look here at example number 6. Let's suppose I want to set up an integral to represent the total area enclosed here by my second picture. Well, if I wanted the total area enclosed, I know that I could get that by just integrating 1/2 my curve squared d theta, and I would need to use the bounds that would allow me to sketch the entire curve. But since those bounds are 0 to pi, that was all I would need. If I was to use 0 to 2 pi, that would actually double trace this, and it would generate double the amount of area. Notice, though, that for finding the area enclosed by this curve, I would need to go ahead and use the bounds 0 to 2 pi. And so this is something definitely when you're working on homework or on practice problems, or when you're thinking about these sorts of questions on an exam, you want to make sure that you, that should say a 2 theta. You want to make sure that you are thinking carefully about how long it takes to sketch each curve that you're given, because otherwise you might incorrectly select the bounds that you need and generate an incorrect result.